Assalamu alaikum wa rahmatullahi wa barakatuh. This is Dr. Munder from University of Technology and Applied Science in Every. Lecture number 2 in Introduction to Cryptography. Today we'll talk about classical cryptography, and this will be include CLO number 2 in the course. In this lecture we will talk about cryptosystems classifications. We will compare two traditional ciphers, two types of traditional cipher, substitution cipher and transposition cipher, and we will take two examples for each one. Somehow we will describe the category of the cipher based on various criteria, as we will see, and we also apply some of the traditional symmetric ciphers as an example of each one, and then we will compare traditional ciphers with some other traditional cryptography or traditional ciphers, um, using their security aspects, either the key or the length of the key or the way they encrypt the text message. Now let's start. Now, before we talk about what's the cryptosystem component, and we say that the cryptosystem component include plain text, include the encryption and decryption algorithm, include the ciphertext, and include the key. Now remember these four components when we talk about the classification or encryption in general. So we can classify a crypto system into four categories based on four criteria. So first of all, we can classify it based on the operation, and if we classify it based on the operation, we will end up with two in the operation we will end up with two types, substitution and transposition. But if you want to classify it based on the number of keys, how many keys they use, you say we have symmetric cryptography and we have asymmetric cryptography. One of them use one key and the other one is using two keys. This one is use one key, this one is using one plus keys, more than one key. If you want to classify it based on the way that the plain text is processed, so we can say as a block, or we can say as stream. A block means what? Divided the text or the plain text into blocks, and the size of the blocks is minimum, for example, 64-bit. But in here, it takes as a bits, okay? Takes as a bits and produce bits, all right? But if you want to classify it as a modern cipher, we say we have a classical algorithm, we have modern cryptography. So there's four ways to classify the crypto systems: operations, based on the operation, based on the number of key, based on the plain text processing, based on the classical against modern ciphers, and each one has what different types of classification. So let's start with now classification based on what? Based on the operation that they used. Okay, the type of operation used. We have two types of operation that can be used in a crypto system, either transforming or substitution. So transforming is basically a substitution and transposition. Substitution and transposition. Substitution, basically each element in the text is what? Is mapped to another element. So let's say that we have letters, for example, these letters. A is mapped to N, B is mapped to O, and C is mapped to P, and so on. Each letter is mapping, for example, to another letter, right? And the output, for example, for hello, H will be mapped to U, so the letter will be U. E will be mapped to R, so R, and L will be mapped to Y, and the same thing here, and O will be mapped to what? Will be mapped to B. So the same thing here, so the hello become U, R, Y, Y, and B. This is called substitution. It's basically mapping letters to each others based on something. Transposition is different. Transposition is about rearranging the letters into a different way. So if you have this text, for example, algorithms, now you say the letters A in position 1, letter L in position 2 and 3, 4, 5, 6, and so on. Alright? So what you do exactly, you have a key and you say the key is position number 3, 5, 2, and so on. So you rearrange the letters in a different way. So the G become at the beginning here, the R come the next, and the L become the third one, and so on, and the A become third one. So this is the way we rearrange the letter in a different way, right? But the other one is different. The substitution is mapping, and the transposition is what is rearranging. Remember that substitution is about mapping the letters to another letter, and transposition is about what, rearranging the letter in a different order. If you want to classify the crypto system based on the number of key, we have two types: symmetric, which use only one key. So if you want to encrypt any message, you use one key, same key here, and both of them need to know share the same key. Alright, they need to use the same exact key in encryption and decryption, which is an easy way, which is the conventional encryption. Basically, it's sometimes we call it secret key. And the other type is called asymmetric, which is basically use what, two key, and sometimes we call it public encryption, public key encryption. So you have two different key. You have public key and private key. All right, each one has a separate different key. The encryption will be with the public key, and the decryption will happen with the private key. So if this is the classification based on the number of key. One of the classification has one key or one secret key is called symmetric, which should be shared between the other the two person. The other type is called asymmetric, which use basically two key, and we call it public key. So we have private key and we have public key. One of them has the private key and the other one has the public key. So basically no one need to know the key of each other, so there's no secret here. Only this one kept with the guy as a secret, and the other key is public key, anyone know it. So if I want to send a message to someone, I use his public key to encrypt the message, and he's the only one can decrypt the key using his private key. This is more secure than what this one. So the second type. With the first type we said based on the way that they operate the text, either by using substitution or using transposition, rearranging or mapping. The second type is using based on the number of keys, so we have symmetric and asymmetric. And the third type, the third classification is basically based on the way that we process the text. So the first one is called a block cipher. Block cipher, basically you have this text, okay? It basically split the text into what? Blocks. We call it what? Block. So each block has a specific size, either 8, 16, or 32, or 64 bits, and the output will be the same. So each block will be encrypted using different way. Each one will be decrypted using different way. All right. This is a very simple and straightforward. So if you have a long text, it will be split into blocks, and the block size is different from an algorithm to an algorithm. Either 18, 16, 32, 60, 46, or 64 bits block size. And these blocks will be encrypted separately using the key, either any key you want, just one key, or using two keys. Okay, and the output will be blocks. Each block will be encrypted in same length of the block using any algorithm, and we will come up with the cipher text by combining these blocks together. The second one is called stream block. Stream block basically is process the input element continuously, so producing one element each time. So if you have, for example, CAE letter, for example, we take the first letter, second letter, and third letter. If you have bits like 0, 1, 1, 0, it will take 0, 1, 1, and 0. So take one bit size each block. It's basically the same as a block, but instead the size of the block is just one bit. So we call it stream. Put them together. That will encrypt each bit separately and then combine them together as a ciphertext using the key. So this is called the block cipher and stream cipher. Stream cipher size is just one bit, but the block ciphertext is varied based on 8, 16, 32, or 64 bits. Now this is the third classification. The last classification, we can classify it as an old way of encryption or new way of encryption. So we call it classical and modern cipher. The classical algorithm is developed like around 50s. So people uh, they still use it for the simple way. It is basically their strength is dependent on how secret is the key they are using or the method they're using. They're not secure anymore because the technology is now more advanced somehow and easy to break them. We will study these algorithms in this chapter. Later on, we will study the modern cryptography, which is basically their strength does not depend on secret protocol. It is more like mathematical computation. It's more like mathematical computation. They depend on mathematical functions to encrypt the thing. They are just more confidential to kind of protect the data integrity and authentication more than the classical algorithm. And we look at two types of modern algorithm. It's called AES and DES, and we'll look into these two in details. But in a classical algorithm, there's so many classical algorithms. We'll study only a few number of them. We'll see in the next slide. So let's summarize this again. Go back to the first slide, and we say that we can summarize the classify the crypto system based on four criteria. The first criteria is called the operation, which is either substitution or transposition. The second one is based on the number of key, with symmetric, which use one key, or asymmetric, which use more than 10 key. We call it public key, or they have like a private and public key. This one classification is based on how the text will be processed, either blocks, and the block size range from 8 bits to 64 bits. Sometimes it goes more than 64 bits in the new algorithm, but the stream is take one element each time, so its size will be 1 bit only, no more than 1 bit. If you want to look at the classification in different way, you saw the old way or the new ways. So we say classical ciphers and modern cipher, which basically classical algorithm and modern cryptography. Now this is how we classify crypto systems based on these four categories. All right, and remember this category and the difference between each one. So if we want to classify them based on like a hierarchical way, you can say this is the ciphers is either classical or modern. The classical, we have two ways: substitution and transposition. In the substitution, we have monoalphabetic or polyalphabetic ciphers, and this is an example of it. This is an example of it. Or we have transposition, which is keyless cipher or keyed cipher. We'll take two examples as well. But when we go to the modern cipher, we say symmetric cipher or asymmetric cipher. Symmetric cipher use one key, which is basically use a block cipher or stream cipher. And as example, there's so many examples on this, and these examples are really very good encryption algorithms. like AES or Blowfish. These two are very strong algorithms. Also, for the modern cipher asymmetric, we have RSA, we have DSA, and we have Diffie-Hellman, which these algorithms are these modern algorithms are depending on mathematical function is stronger than this tree summarize the whole classification of the crypto system. So if you try to memorize or understand this hierarchical order of the cipher classification, that will make it the rest of the slide easy on you. The next one will be talking about substitution ciphers. So let's start with the first classification, which is called the substitution cipher. The substitution cipher is much better in the old age. Okay, so we have two types for this substitution type. We have monoalphabetic and we have polyalphabetics. Okay, so both of them are substitution. As an example of monoalphabetic is Caesar cipher. As an example of polyalphabetic is vinegar cipher. Okay, so for the monoalphabetic, it's as we said, the substitution is just a mapping, you know, mapping the letter to another letter. So letter A will be mapped to a letter X, for example. All right, just a mapping. All right, so the letter A will be replaced by what? By letter X, for example. All right, so each character of the plain text is replaced with a corresponding character in the cipher text. It's very simple and straightforward. We'll take an example. But when you to say the other type is polyalphabetic substitution, is basically depending on an array to replace the letter in with another letter. Both of them are working on replacing, but monoalphabetic is just one alphabetic, okay, replaced by one. But when you say polyalphabetic, it's basically multiple monoalphabetic. It's just multiple of monoalphabetic, just repeating monoalphabetics more than one time. Let's take an example and say we can understand that. Now, the first substitution type is called Caesar cipher, which is a very old cryptography algorithm or a classical algorithm. It's basically there's a history in that. You can you know, look at the history. It was a very important one in the old times. It's the first substitution cipher invented by Julius Caesar. It involved replacing it's substitution, so it replaces each letter of the alphabet with a letter standing some fixed places further down to the alphabetics. For example, you have initial alphabetic is what? A, B, C, D until Z. Is that? What? A, B, C, D, E, F, G, H until Z. This is the normal order, okay? But when you encrypted it, you can see that D, E, F. What happened to the A, B, C? They moved to the end. So it's become, this is the A, B, C now, become here, okay? It moved the A, and then the B, and then the C. So it's become, the letter will start from D now, okay? And the last letter become what? C. So A will be replaced with D, B will be replaced with E, and so on. H will be replaced with J, and S will be replaced with W, and W will be replaced with Z, and Z will be replaced with C. So it is basically just replacing the letter by multiple somehow, you know, another letter. Let's take an example, okay? This is an example called meet me after the toga party. Now we have to define the substitution shift. We have to define what we call it, how many shifts that we're gonna make. Okay, you can choose the number from 1, 2, 3 until any number until 26, because we have only 26 letters. Okay, you have 26 letter. Choosing more number of shift does not make the algorithm actually more complex. It's very simple one. So if we choose 3 character, that means we're gonna move the A and the B and the C, the first 3 character, to the end. We make shift for them. We move them to the end. So the new order will become what? D, E, F. So the letter now, the encryption alphabetic, will start from D. Alright? So if I have this sentence, meet me after the toga party. Now, where's the M here? The M is replaced with what? With P. Alright? And the E is replaced with H. So you can see P, H, H. Okay, what about the T here? You can look at the T is replaced with what? With W. So this is the T replaced with the W. So and the M replaced with the P and the E with the H and so on. And you can see the Y is replaced with what? With B. Alright, so this is the cipher text now. This has become the cipher text now. It's the cipher text, and this is called the plain text or the message. This is the plain text or the message. All right, this is a very good one. But if you want to make the shift, for example, one letter, now you have to move only the, so the letter will start B, C, D and continue until Z and A become. This is one shift. Okay, if you want to do one shift only, just one shift for the letters. All right, if you want to do 2 shift, all right, now the letter will start from where? From C, right, D and until Z, but A will come here at the end and B move to there. If you want to say 5, say 1, 2, 3, 4, 5, so the letter will start from F. If you say 5 shift, the letter will start from F until Z, and the rest of the letter will be moved where? To the end. The A, B, C, D and E move to the end. So how many shifts? You just put them underneath each other in order, and then you can do that. All right, so if you have any sentence, you can just play with it. Now you have an activity here. You need to do this activity. So just try to shift the alphabetic letter by X factor. You can choose X. Let's make X fixed. You can choose it 2, for example. Let's make X 2, or you can choose 3 or 4 or 5 and put the new order. So if I say 2, that means number A and B will move to the end. So we'll start from C, all right, and then D, and then E, and to the what? To Z will become here, and A will move here, and B will move here. See, finish this activity and see what you can do. If you can, encrypt any text in the message, and try to decrypt it in the same way. Right, decryption is easy, so you just go back to the old order. So it's go both way. Okay, if you want to encrypt this way, if you want to decrypt, you go the other way. All right, this is a very simple and straightforward algorithm. Now Caesar Cyber, this is an example of Caesar Cyber. This is the letters. If you want a 1 shift, this is the order, the new order, 2 shift, 3 shift or 4 shift. All right, this is plain text. T is mapped to W. How is mapped to W? This is the first shift. Okay, if it's the 4th shift, T will be mapped to what? To F. Remember, this is T, the first, second, 3rd and 4th shift. All right, now if it is the first shift, will be mapped to what? To W. If it's a second shift, we map to Z. If it's the 3rd shift, we map to C. It's so the letter that mapped to, it depends on how many shifts you will use. All right. Notice how the letter K is transformed into W or F depending on its order or appearance in the. Try to encrypt your name. All right. Let's say my name is Monte. I'm gonna use the first shift or the second shift, let's say. Okay, quickly I'll do it. So the M here with the second shift, where's the M? M with the second shift is S. Okay, and the O is U, and the N is T, and the T is Z. I'm using the second shift. Okay, remember the second shift, and the T is Z, and the H again. We go to the H is N, and the E is K, and the R is going to be X. This is the second shift. All right, if you want to do the fourth shift, the encryption will be different. The fourth shift is going to be, if you want to look at the M here, it will become Y, and the O become A, and the T become F, and the we forgot the N becomes Z, sorry, Z, and the T become F, and the H will become T, and the N will become Z. Okay, and we already, no, I'm not encrypting this one, sorry. So the M, let's make it here Y, and the O is A. I'm looking at my name. Okay, the N here is gonna be Z, the T will be F, and the H will be T again, and the E will be last one Q, and the E will be, sorry, the E already mentioned that, the R will be D. So you can see different cipher, it depends on the number of shifts. Okay, now I'll stop here and then I'll talk about vinegar cipher in the second part.